Bismillahirrahmanirrahim. Welcome to ceramic processing class. This video is a part of lecture series on the course ceramic processing. In this video, we will discuss sol gel processing. In this first part of the video, we will discuss sol gel processing, sol gel method, advantages of sol gel processing, disadvantages of sol gel processing, and the applications. So let's start with an introduction to what is sol gel processing. The sol gel process is very long, known since the late 1800s. The versatility of the technique has been rediscovered in the early 1970s when glasses were produced without high temperature melting processes. Sol gel is a chemical solution process used to make ceramics and glass materials in the form of thin films, fibers, or powders. A sol used in sol gel, the sol is a suspension of colloidal particles in a liquid or a solution of polymer molecules. So either a solution of a liquid or a polymer, these are the colloidal particles that are dispersed in the solutions. The term gel, it refers to semi-rigid mass formed when the colloidal particles are linked to form a network, or when the polymer molecules are cross-linked or they are interlinked in the solution. So it is referred to as gel. So the term sol gel is a process, we can say that, we can define that sol gel is a process that involves the preparation of a sol, the gelation of the sol, and the removal of a liquid. It is widely used for preparation of ceramic materials. Two different sol gel processing routes are commonly distinguished. The particulate or the colloidal gel route, in which the sol consists of dense colloidal particles having a size ranging from 1 to 1000 nanometers, and the other route is the polymeric gel route. In the polymeric gel route, the sol consists of polymer chains that has no dense particles, and its size ranges for 1 nanometer. But in many cases, when the particle size approaches the lower limit of the colloidal size range, it is very difficult to distinguish between either it is particulate gel or the polymeric gel. So the distinction between the particulate and the polymeric system becomes unclear. Now let's proceed with the procedure of sol gel method. How can we prepare different ceramics material by using the sol gel method? Let's see. Here you can see a picture. It is a schematic illustration of the routes that can be followed in sol gel processing. A sol, in the first step, here you can see, in the first step, a metal organic compounds is formed in a solution. A solution of metal organic compounds are formed in this first step. These metal organic compounds, which we commonly known as metal alkaloids or the metal chlorides, these are dispersed in a solution that is water plus the alcohol. The appropriate alcohol we use in appropriate amount, and the metal alkaloids are dispersed in the solution. Under constant stirring at temperature slightly above room temperature, which is normally kept to about 50 to 90 centigrade, and with suitable concentration of the reactants, and as well as the pH of the solution. Hydrolysis and condensation reaction may occur, leading to formation of polymer chains. Here you can see in a picture that this solution was dispersed and a sol was formed, in which the colloidal particles, are randomly moving. They are doing the Brownlee's motion, and as it is a stable sol, so you can see that the colloidal particles are dispersed homogeneously. And after the process of hydrolysis and condensation, we get a gel, and this gel is leading the for we can see the polymer chains created over here. And when the liquid phase of a gel is replaced by a gas in such a way that its solid network is retained with only a slight or no shrinkage by a gas, in such a way that its solid network remains the same, it forms a gel which is known as the aerogel. Here the liquid has been removed and has been replaced by the gas. You can see the polymer chain, the solid network, it has been retained, it remains the same, and this form is known as the aerogel. It is achieved under supercritical conditions. For the supercritical condition, we refer that at the temperature and pressure which is above critical point, where distinction between the liquid and the gas phases do not exist. That state is called the supercritical. So at here there is shrinkage. Although the network is retained the same, but there is a shrinkage over here due to extraction of the solvent, and this shrinkage is very low. It is about less than 15%. Okay. When we evaporate the solvent, here the solvent was extracted and it was replaced by a gas, and here the solvent has been removed, and it has been removed by evaporation. So the liquid phase of the gel, when removed by the solvent, when removed, the liquid removed or the solvent removed from the gel by evaporation, we get an exogel or the zero gel. It is also known as the zero gel. It may be retained its original shape, but there is a huge amount of shrinkage. But often we also see cracks due to extreme shrinkage that is experienced when it is being dried, and by the evaporation of the solid, this exogel, when formed, it has a shrinkage of more than 90%. So after attaining this zero gel, when it is sintered to a particular temperature, these provide a dense ceramics. And if we see over here, if this sole is placed on a film or a substrate, it can be either by spin coating or dip coating or any other coating method. If it is placed, if it forms a zero gel film on the substrate, and when it is heated or sintered, it forms a dense film on the substrate. So by using the sol gel method, we can prepare a dense material as well as the thin material. So here are the steps that are included over here in the picture. From it you can see clearly how the schematic route has been followed in the sol gel processing. First, the metal alkaloid solution, which is being used for the preparation of the sol. Then it is followed by the hydrolysis and condensation reaction. Next, polymer chains or the gel is formed. In the fourth step, solvent extraction. It provides us with the aerogel, and evaporation of the solvent, it provides us with the zero gel. And when this zero gel is sintered, we can get a dense ceramic, or when is zero gel is placed on a film, we get a dense film. A basic problem, therefore, is understanding how the rates of the chemical reactions are controlled by the processing variables such as chemical composition of the processor, the precursor, concentration of the reactants, pH of the solution, and the temperature. All these have a great role or influence on the sol gel processing. The chemical reactions that occur during the conversion of the precursor solution to gel have a very significant influence on the structure and the chemical homogeneity of the gel. So there is a problem. Problem becomes more complex when a solution with more than, when we consider a solution having more than uh, two or more alkaloids are used. Means that we want to make a multi-component gel. Then during the fabrication of the multi-component gel having more than one metal cation, there will be a loss of chemical homogeneity. If steps are not taken to control the reaction after preparation, the gel contains a large amount of liquid existing in fine interconnected channels, and it must be dry prior to the conversion to a useful material. So, here these are the basic chemical, these variables should be considered, otherwise, the desired material to be fabricated from the sol gel method cannot be achieved. Here, another problem is the drying. During the drying or evaporation of the gel to form the zero gel, it under certain normal condition, it gives rise to capillary pressure that causes shrinkage of the gel network. The resulting dried gel, that is the zero gel, the in that capillary pressure is quite large, and this capillary pressure uh, is more large in polymeric gel because the pores are normally much finer than those in colloidal gel or the particular gel. Consequently, severe problems can be encountered with the wrapping and the cracking of the gel. So the two general approaches are there. Two general approaches have been used to avoid these problems. The use of chemicals added to the precursor solution prior to gelation, referred to as drying controlled chemical additives. These drying controlled chemical additives prevent relatively rapid drying. And second, the removal of liquid under supercritical condition. It eliminates the liquid vapor interface, and thereby it prevents the development of capillary stresses. Thus, the gel undergoes relatively little shrinkage. The dry gel called the aerogel is therefore fragile and may shrink considerably during firing. In some cases, crystallization of the gel prior to full densification may limit the sintering rate for composition that are crystallizable. So this was all about sol gel processing. Let's see its various advantages. Most gels have an amorphous structure even after drying and contains fine pores. Either it is particular gel or the polymeric gel, both have usually have an amorphous structure. If a dense ceramics is required at the end product, means we need a dense product or a crystalline material, these characteristics are very favorable. That is the amorphous structure and the fine pores. They are very favorable for good densification during sintering when compared to the production of similar ceramics by using the traditional processing routes involving the compaction and the sintering process, by which we can get the crystalline particle, a reduction in the sintering temperature, that those traditional processing routes require high temperature. As compared to that, the soul gel processing requires a very low, considerably low sintering temperature. So when we can get a crystalline material, the same dense material having the same characteristic at considerably low sintering temperature. And this case is particularly for the polymeric gels. So the polymeric gels have this characteristic advantage. So the sol gel process provides this advantage over certain other traditional processing routes. The second advantage, it provides substantial benefits such as various shapes, special shapes we can obtain directly from the gel method, that are the monolithics, films, fibers, particles with controlled chemical composition, microstructure, and low processing temperature. So by using this we can, so these were the three advantages we get from the sol gel processing. First is a good densified material. Second, the temperature, sintering temperature is very low as compared to the traditional processing temperature, but traditional processing routes and various shapes can be obtained. But there are several disadvantages of sol gel processing or mentioned over here. Many metal alkaloids that are the main precursors for the sol gel process, they are very expensive. They are fairly expensive, and most are very sensitive to moisture. So, a care or a special handling, a dry environment, an inert atmosphere is required to handle these metal alkaloids. And the large shrinkage, second is the large shrinkage of the gel during the drying, as we have discussed it earlier, and this during the sintering it makes dimension control of the large particle difficult because of the shrinkage. So it is often very difficult to obtain monolithic gels thicker than a few millimeters, or films thicker than 1 meter without cracking. So the drying process, in which cracking and wrapping is the main drawback of this sol gel processing. The third one is the sol gel process is therefore rarely used for the production of thick films or articles because of the shrinkage problem. Instead, it has been considerably used for the production of small or thin articles such as films, fibers, and powder. So, it has been restricted for the use for making thick films and large size articles, but it is suitable for certain small or thin articles, films, fibers, and powder. We can make that very easily. So here are some applications of sol gel method, as uh, it can be used for the production of various articles. Here we can see over here in the figure, it is a solution having stable colloids. This sol which has been created, which after hydrolysis and condensation reaction converts into a gel, if this sol is processed, it can be used in the form of powder, films, patterns, or fibers. And if this gel, it can also be used for the fabrication of powders and the monolithics. So these were the applications of sol gel method. And the sol gel method, the most biggest advantage that the sol gel method provides us is the chemical homogeneity, and second thing is the low processing temperature that the sol gel will has been providing us, and it is providing us with the dense or crystalline material having the same characteristic, or we can say that a better having a better characteristic as compared to the materials which we obtain from certain other processing routes. So this was all about soul gel processing, its procedure, and the advantages and the disadvantages.